This lesson is about circles and arcs. And the objective is to find the measures of central angles and arcs and to find the circumference and arc length of circles. So there are a lot of definitions in this lesson. There's actually 2 pages of lessons in your notes. So it is a little longer lesson because of all the definitions in here. So let's get started on the definitions on the left side. Definition of a circle. A circle in a plane is the set of all points equidistant from a given point called the center. And you name a circle by its center. So if you have a circle and the center point and the point in the center is P, then we would call that circle P. So the symbol for a circle is just a small circle with a dot in the middle representing the center, and you name it by its center point. So that's circle P. The second definition, you have a diameter. And a diameter is a segment that contains the center of a circle and has both end points on the circle. So if we draw a diameter of this circle, we'll call that AB. So segment AB in that circle is a diameter because it has its endpoints on the circle and goes through the center. Now radius has one endpoint at the center and the other endpoint on the circle. So in this particular circle that I drew up here, PA would be a radius and PB is also a radius. The other relationship between a diameter and a radius is that the diameter is twice the radius, or the radius is half of the diameter. The next definition we have is for congruent radii. Congruent circles have congruent radii. The next definition is a central angle. A central angle is an angle whose vertex is the center of the circle. So if we look at, draw another circle down here, center, we have P again, and we have this central angle because the angle is, the vertex of the angle is the center of the circle. So we have circle P, and we have angle P in this particular example. That is the central angle. An arc is part of a circle, and in this particular circle that we drew here, arc, you can call it arc AB. And you make it with an arc symbol over the top. AB is an arc of that circle. Next definition is a semicircle. So a semicircle is a type of arc that is half of a circle. So it's 180 degrees. Next definition is a minor arc. A minor arc is smaller than a semicircle, and that means it's less than 180 degrees. Next type of arc is a major arc. A major arc is larger than a semicircle. It's greater than 180 degrees. Now, most semicircles are named with 3 points on the arc. Minor arcs are named with 2 points, and major arcs are named with 3. So let me see if I can give you an example of, so we have circle P again, and we have, let's see, AB is the diameter, and then let's do point C. I know that's out of order, but that should give me enough. The semicircle I would name as arc. I could name it arc ACB. ACB. And a minor arc that's less than 180 degrees. There are a couple of them here. Arc AC would be less than 180 degrees, and arc CB would be less than. So I'm just going to name those with 2 letters. And the major arc, a major arc is greater than 180. There's a couple of those I see here. If I start at C, go around through A, and end at point B, that's a major arc. Or I could have started at C, gone through B, and ended at A, and that would have been a different major arc. The arc measure, the measure of a minor arc is equal to the measure of its corresponding central angle. So if you know the measure of the central angle, then you know the measure of its corresponding minor arc. The measure of a major arc is going to be the measure of the related minor arc subtracted from 360. The measure of a semicircle is 180. We'd already said that. And definition for adjacent arcs are arcs of the same circle that have exactly one point in common. So let's look at a couple of problems over on the right side of the page that use these definitions. Problem 1, you're just naming the arcs. So in A, it says, what are the minor arcs of circle C? So for this part, I usually start with one point and work my way around the circle. So I'm going to start with point A and name the minor arcs from that point. So AB is one of the minor arcs. And then from B to E is another minor arc. From E to D is another minor arc. And from D to A. Those are all minor arcs. For part B, it asks what are the semicircles of circle C. So once again, if I start with point A, I would name one of the semicircles ABE. It would end at point E because A and E are the endpoints of that diameter. But the other side of that diameter is also a semicircle. So if I start with A and go down to D and end at E, that is another semicircle. If you start with point B, go to the right through E and end at D, that is one semicircle. And if I had started at B, gone to the left through A, and then ended at D, that's a different semicircle. So those are the semicircles that are part of that circle. And then part C asks what are the major arcs of circle C that contain point B. So let's start at point B. Start at point B and name a major arc. So if I start at B, go through E, and end at point A, that is one. I could have named it BDA as well, and it would have been the same arc. Okay, you just have to have one other point between your endpoints of the arc. If you start at point E, go through point D, and end at B, that's another major arc that contains B. I could have also named it EAB, and it would have been the same arc. If I start with D and go through B and end at E, That's another arc that contains point B. Could have named it DAE and it would have still contained point B, but I put point B in there just to show it is containing it. Let's see, in the last one, if I start at A and go through B and end at D, that's another arc that contains point B. And problem 2, we're finding the measures of arcs. Now they have a couple of typos on here. In the first part A, when it asks what is the measure of arc TOU, it should not have been TOU. It should have just been arc TU, because TOU is the central angle. But that is what the measure of that arc is, the same as the central angle, which is 60 degrees. The measure of arc TUR, if you start with T, put a different color, start with T, go through U, and end at R. That's a semicircle. So that means it's 180 degrees. STU, if you start with S and go through T and end at U, the measure of that arc is going to be 20 plus 60. So that's going to be an 80-degree arc. And finally, this last one, once again, arc ROU should not have been ROU, should have been just RU, because ROU, once again, is that angle. But he wants to know the measure of that corresponding arc, which is going to be the same as that angle. So you got to figure out the measure of the angle, since that is a semicircle minus 60 degrees. So that's 180 minus the 60 degrees is 120 degrees. On our second page of notes, there's a postulate, which is the arc addition postulate. It states that the measure of an arc formed by two adjacent arcs is going to be the sum of the measures of those two arcs. Definition of circumference. The circumference of a circle is the distance around the circle. And we also need to know what the number pi is. The number pi is the ratio of the circumference of a circle to its diameter. So you could write that, pi is equal to the ratio of circumference over the diameter. And that leads into the next theorem, which is gives us formula for the circumference of a circle. So the circumference of a circle is pi times its diameter. And since diameter is equal to 2 times the radius, that can also be either pi times diameter or pi times 2 times the radius, which is 2 pi r. Depends on what the problem gives you as to which one of those you might want to use, whether it gives you the diameter or the radius. So to approximate pi, you can either use 3.14, you could use a fraction 22 over 7, or you can use the pi key on your calculator, which is really the easiest thing to do. The definition of coplanar circles that have the same center are concentric circles. So coplanar circles have the same center. So here we have these two circles, they have the same center, so those are concentric circles. Kind of think of dropping a pebble into a pond would create concentric circles. Next definition is arc length. The arc length is going to be a fraction of the circle's circumference. Now that's different than the measure of an arc, which is measured in degrees. The measure of an arc is the same as the measure of its central angle. Those are measured in degrees. This is talking about the length of an arc. It's a linear measurement. It's a fraction or a piece of the circle's circumference. So if we look at arc length, the length of an arc of a circle is going to be the product of the circumference and the ratio or fraction of the circle, which is going to be the measure of the arc divided by 360. So we'll look at this in some problems. That'll help it make more sense. Last definition is for congruent arcs. So congruent arcs, arcs that have the same measure and are in the same circle or in congruent circles. So let's look at these last two problems on the right. In problem 3, we're finding circumference. We're using circumference to solve this problem. It says a merry-go-round has seats that are 7 feet from the center of the ride and 10 feet from the center. How much further does a child seated on the outside loop travel than a child seated on the inside loop in one complete revolution? So let's sketch a diagram of this problem. So we have a merry-go-round with 2 sets of seats. Okay, so there's the center. So one set of seats has a radius of 7. It's 7 away from the center. And the other set of seats is 10 feet away from the center. So you just need to find the circumference of each of these circles and find the difference to see how much further, how much longer the circumference is on that red circle than the ones that are on the blue one. So let's look at circumference is 2 times, we use 2 pi times radius since they gave us radius in the problem. So on that outside circle we have 2 times pi times 10. So you've got 20 pi, which is approximately 62.83 feet for that outside, those outside seats. Now on the inside seats, the circumference is going to be, once again, 2 pi times the radius, but here the radius is 7 on those inside seats. So you got 14 pi, which is approximately 43.98 feet. So if you look at the difference between those circumferences, you've got 62.83 minus 43.98 should give you 18.85 feet is how much further a child on the outside loop would go than the ones on the inside loop. This last problem is finding arc length. In the first problem, A, it asks you to find the length of arc CD. So on the left side of the page is your theorem for arc length. So we need to find the fraction of the circle. So the fraction of the circle is going to be the measure of this arc. This is a 90-degree angle for the central angle. So the measure of that arc is 90 degrees. So the fraction of the circle is 90 divided by 360. And we need to multiply that times the circumference of the circle, which is 2 pi r. So 2 times pi, and the radius of this circle is 4.5 because they give you the diameter. So you could have used pi times diameter or 2 pi r. We use 4.5 since I've got it up here. 4.5. So multiply that together And you're going to get 90 over 360 is 9 pi. Times 9 pi. And then do some canceling here. 9 will go into 360 40 times. And 90 over 40 will reduce down to 9/4 pi, which is approximately equal to 7.1 centimeters. And problem 2 will be the B part of this. We want the length of arc STR. So it starts at S, goes through T, and ends at R. So we want the length of that. So we need to find the measure of it first. The measure of that arc is going to be 360 minus 100. It's associated minor arc, so that's 260. So this is 260 degrees. So the fraction of the circumference we want is 260 divided by 360. And we're going to multiply that. They did just give us the radius here, so we're going to do 2 times pi times the radius, which is 4. So if you multiply that out on your calculator, you're going to approximately get 18.2 feet.